So, Rolando, that was fascinating. There's a ton to unpack, and I feel like where do we start? And that's why we have the panel here. So I'm going to bring in the panelists. We'll start with Varsha. Varsha, if you could turn on your camera. So Varsha is with Woven Planet, and Varsha, you're a software engineer, and you heard, what Rolando also said, and it would be interesting to see what your take is on a highest level from his statements. But before you do this, please unmute yourself and introduce yourself. Let us know what you do at Woven Planet.
Yeah, thanks, Ronaldo, for the interesting presentation. And hey, guys, I'm Varsha. I'm part of Woven Planet. We are basically a startup within Toyota working on autonomous car. And I'm part of perception engineering team working on ground truth perception and also some on the infrastructure side, specifically the DAG part that Ronaldo was talking about. And yeah, we use Flight for a lot of our DAGs. Yeah, Martin, do you have a specific question? Yeah, how do you want to do this?
Yeah, absolutely. So I just have one very specific. Obviously, you're working on the infrastructure part. We've seen the layered approach that Ronaldo had earlier. Do we underestimate in machine learning production the role of infrastructure? What is your take on that?
Yes, we do in some part. Like, let's say we focus a lot on iteration and experimentation, but for an ML engineer to do that, a lot of it depends on how good their infrastructure is. Does their infrastructure let them, does it facilitate them? For example, when we talk about iteration and experimentation, right? We don't necessarily have to rerun all parts of their DAG or whatever pipeline or the steps that they have defined. Let's say in our case we use Flight, and a few things that really helps us is, let's say, caching. We don't want to rerun everything. So does your infrastructure provide caching for you to simply skip over and only rerun some parts where your config is updated or maybe your model is updated? Another thing that, at least for us, is very important is versioning, not just with your model, but also your dataset versioning. And how does that translate to how well does your infra help you with that? Let's say I've trained something on a particular day with these inputs. So what was the original data set that it has? And versioning, caching, and most importantly, another feature, because we're a startup, we don't have the, keep GPU warm that Ronaldo was talking about. For us, it's always a fight for GPU resources and contention. So how well does your infrastructure provide that abstraction where, when you are given a GPU, how efficiently could you just run that and train and make sure that your other steps and processes are outside of your GPU warm time. So yeah, infrastructure is definitely underestimated. So yeah, both MLOps and infra kind of go hand in hand.
Fantastic. So we're going to spend a little bit more time later when we talk about velocity on versioning, one of the two of the two V's that Rolando brought up, and I think that's going to be how do we actually get the balance there. Thank you so much, Varsha. Next, I would like, so please mute yourself and stay. You can leave the video on because we're going to go to a panel setting here. But I want to bring in DJ Rich. DJ, you're with Lyft. Hello. So please unmute yourself and introduce yourself and tell us what you do.
Sure. Hi, everyone. My name is DJ. I'm a data scientist at Lyft, and I work on their causal forecasting system. So that's a system that we've been working on for the past 3 years. It basically allows us to do budgeting and pricing over like a 3-month time horizon. And it's exceptional in the sense that, it's, of course I'm going to say that. But it does forecasting and it needs to match all these experiments. That's why we get to call it causal. And I guess the other sort of specific challenge that it has is it requires models from many different teams. So from the model development side, it's almost like a distributed test. We're actually not very compute heavy, but we have a lot of different people adding their models to a larger system. So, yeah.
Interesting. So you could be actually kind of like what we heard earlier traditionally, that we have a lot of model throughput, but now the way Rolando put it is like, well, Now we go through velocity, not necessarily the number of the models matters, but what comes out of it. So we're going to spend a little bit more time later. Thank you so much, DJ. I think super interesting. Next, we have Brian. So Brian, you are an ML infra engineer. Tell us a little bit about yourself, unmute yourself, and give us an understanding about what's happening on MLOps in your world.
Yeah, thank you, Martin. Yeah, so my name is Brian, and I'm an ML engineer or ML infrastructure engineer at Stripe. Specifically, we kind of break apart ML infrastructure into different parts, and specifically, I focus more on the exploration aspect of ML. And so, what that kind of entails is the services that we own are more around training, notebooking, and basically now we're actually trying to move a lot of those processes onto Flight. Because Flight just offers a lot of the things that we're looking for, primarily velocity, which is the primary V that I would say that we're focused on.
Fantastic. Yeah, I like that term. So we're going to talk a lot about velocity and how to stay sane while increasing velocity. I think that's kind of like the balance we're trying to find. Thanks, Brian. I saw that Michael, you joined us. Please unmute your, or turn on your camera, unmute your microphone, introduce yourself, and tell us what you do at Striveworks.
Let's see. Yeah, I'm Michael. I'm a software engineer at Striveworks. We have a MLOps platform called Chariot that really focuses on the life cycle of a model. And so everything from you upload a raw data set, need to annotate that data set, need to train it based on some training parameters, model architecture, different permutations of a data set, whatever transformations you want to do there, cataloging that model, serving that model up so you can perform inferences, and then even detecting whenever you get some model drift, things like that. And so we focus on that whole thing. We use Flight, so since we focus on all that stuff, we still need to use our models in workflows. And so we chose to go with Flight. We looked into different technologies, but Flight hit our use cases. And so now we're able to focus on that model development part without having to really think about, like, how are we going to productionize this? We have to release our platform all in one go. So we work with a lot of highly sensitive data. We work with government contractors. And so everything has to be deployed together. So Flight helps us do that. And while we have these things done in a Jupyter notebook, that is not a productionized version of a model. And we're also a startup, so I was smiling whenever Varsha was talking earlier about having to fight for GPUs, and that's part of the scheduling part of the model life cycle, and that is that's a fun topic.
Michael, thank you so much. I also love your role. I mean, you're DevOps engineer that is on MLOps, so that sits right between data science to a certain extent, and then engineer on the other side very often. So we're going to have a lot of really interesting topics to discuss in a second. So thank you so much. I want to bring in Fabio. Fabio, please unmute yourself and introduce yourself and tell us what you're doing in the context of MLOps.
Hey everyone. Sorry, my voice. I had a cold the last days. Hey everyone. I'm Fabio. I work at a company called Recogni. We built a custom accelerator chip for self-driving cars that's crazy times faster than competitors. And I work in the software engineering team that provides an MLOps platform for a perception team who builds the models to run on the chip to steer the cars. And we leverage tools like Kubernetes and Flight to just make experimentation faster and to help us keep track of the experiments we're running, being able to reproduce them. Before I started working in this role, I built up the MLOps team at a machine learning solutions provider, and there my team built a kind of an internal developer platform that allows ML engineers to bring up infrastructure that they need to train or develop and productionize their models in a self-serve fashion. And for that, it's really important that you can abstract away the complexity of the tooling that is typically involved. And for that, things like Kubernetes and Flight are just great. Back then, we did a comparison of all the different orchestration tooling out there. And with everyone, it was kind of cumbersome until we then settled on the stack that we ended up using. And everything just ticked, and we were like, okay, if we, like, in hindsight, it's easy to say that, but we should have built it the same way if we had done it ourselves. Yeah, I originally, or before working as an MLOps engineer, I worked as an ML engineer, and then kind of realized that the exciting part is happening around the model, very often at least, or at least I felt so. But also because there was just a lot of pain managing the infrastructure, and I figured, okay, this has to be easier, right? Like, not everybody can become an infrastructure expert. Most ML engineers don't want that. Let's find an easier way for this.
Fantastic. Fabio, thank you so much. So before, I want to bring in Rolando too. So Rolando, please, you have introduced yourself earlier, but I want to quote 3 things you said in your paper and then bring you in and the entire panel now. Those 3 things struck me. First thing you said is people spend a significant amount of time on less glamorous aspects of ML, like maintaining and monitoring the ML pipelines. And I think some of the people here will say, well, it might be less glamorous, but it's really, the essence of making this whole thing flow. That's one thing. The second statement you made was paranoia caused by ML debugging trauma. So when I read that, I go like, wow, I mean, this must be pretty severe. And obviously people go through this. And we need, Varsha said it, I think, right earlier, we need versioning. We need really to know where we are so we can take a step back at any given time, Michael, as well. And last but not least, having high velocity could mean drowning in a sea of versions, and so that we don't want that either. So what I wanted to start with this whole conversation here is, like, you have now a group that invested a little different. It's a different group than the group you worked with in your study, right? This group had made an investment on an infrastructure play. So I just wanted to see if there's an area where you are curious and want to ask the group, hey, is something more or less a problem, specifically when it comes to velocity. I think velocity and versioning, those are kind of like the things that go in 2 different directions, and I feel like that's what everybody tries to solve. Of course, validation we want to do a little bit sooner, but I was just wondering if you have a question and if you want to see if there's anything different with this group versus the other group.
Sure. So one quick question. I'm thinking of the code. So we use grounded theory method and then bottom-up coding. So as I'm listening to some of these questions, I'm thinking about the codes that we parse through the transcripts. Something that I remember is the phrase rip and replace. So especially with small companies, the ML engineers were often, responsible for the entire workflow of MLOps. And because of that same, employee turnover, something that was common was someone would develop the infrastructure and then they would leave the company and then they would hire another ML engineer and they would rip and replace. And then, okay, that other engineer liked Scala. Well, I like Spark SQL. And so they would, abandon the components and start from scratch. This would be something that could take up as much as a year, but, because it would later help them with incremental changes and deployment and kind of like lead the team, they kind of thought that it was, valid. I think with larger companies, they would eventually converge to an infrastructure that they trusted and that had been around for a longer time. I asked someone from a large company if this kind of like organic growth of infrastructure was normal and benevolent, and they corrected me and they said that they would hesitate to call it ad hoc, even though they hadn't, developed it from start to finish, just because there had been so much engineering that had gone into this. So I know that eventually companies, as they grow in maturity, they do converge towards a trusted infrastructure. There's similarities, but there's similarities in concepts. I felt like different people had different preferences, different attitudes. Like you said, Martin, some people might want to break more in favor of high velocity. Other people might want to keep more simplicity with reduced versions and stuff. So it's going to matter. Company culture is going to make a difference. So I guess asking the panel here is like, what are some of the benefits from how would someone outsource to a third party this infrastructure service? And how do you incorporate that into your workflow?
Good question. So I think if it's clear, I'm happy to. I feel like one of the interesting questions here is maybe on Michael's on your side. I think obviously you do governmental work and you have found a platform. You know, I feel like really it's interesting. How did you get there? I feel like that's one piece, and then what's the advice for others to jump to make a similar step that you have made so far? What was the epiphany that you had to get to?
Right. Well, our whole one of our, we were originally a services company that would take on government contracts and send out a software engineer and a data scientist together. So anytime there was like a data scientist wasn't just responsible for the whole model life cycle, a software engineer was there to help out with that as well. And so they would tag team on whatever was needed to help the mission, but also it wasn't just the sole responsibility of the data scientist. And after a while, we pivoted towards creating a MLOps platform. And so, can we scope down a bit of that question?
Rolando, do you want to scope it down? Rolando, do you want
Sorry,
to scope it down a little bit? How do people take advantage of that service? Or
Yeah, so the infrastructure part was important, right? So I feel like there was almost like I could break up the time that the ML engineer spent into two halves, and the first half was build the infrastructure, and the second half was the four stages. And so if I can just not build the infrastructure, if there's like an out-of-the-box solution for me to do MLOps, like that would be great, you know? So I guess what was your experience with adopting this infrastructure, lessons learned, pain points, that kind of discussion?
Yeah, so our data scientists tried building out a platform that would help them, you know, not have to worry about this model development lifecycle, and that included things like versioning and scheduling and actually serving up the model. But we found we needed to really invest in making this like both simpler for some use cases and also giving a whole bunch of like control over different options. So there's like, here's the data, I need a good object detection model, go. I don't want to have to worry about how many resources I'm going to take up. And then you have the other end of things where, you know, I am a data scientist. I want to be able to play around with every little thing and experiment on these models. So we have both of these use cases. Whenever we're out there, you know, on these missions, we may need to be a bit more technical on things. But once we figure out, like, no, this model works, we may need to just retrain that model with new data that's coming in. So in the beginning, it may be really experimental, and then later on, it is just like, I need to quickly retrain a model. I don't want to have to go through the whole rigmarole of what I've done before in that experimenting phase. I just want to click a button that says, hey, here's my model, and here's the new data set. Go retrain it. And that's,
if I just chime in here right now, Mike, if I just chime in here right now and bring in DJ, because I think I want to extend that view a little bit from a data scientist point of view, and then go all the way across to the engineering part, because that's where worlds collide, and I feel like that's what, you know, we very often sit at the in between two chairs. And I think DJ, you know exactly where I'm coming from. So what was your discovery journey? What pain did it take for you as a data scientist to look at an infrastructure solution to say, well, I'm going to be a part of that?
Well, funny enough, I actually resisted flight in the first place because I didn't know anything about it. We were on Airflow, and so we had working models, but we had an evangelist on our side being like, you got to use flight, and then it was just much easier. The UI was better. Yeah, it's a little bit hard to recall all the. I'm thinking. I mean, hmm. I mean, probably the UI was the thing that caught me by surprise, because Airflow, we had this terrible UI that was just way too complicated and unfriendly in a lot of different regards. And then the Flight UI just had it task-wise, which made it a lot easier. Also, one thing that was huge was it's very Python agnostic. So we had to pull this extremely dirty trick to get Airflow to work, which was using like a Python string, like a giant string, and then manually managing the image. And then that was the first thing that we got to tear out. And so, yeah. So once we were into Flight, it was just, you could go directly from the local situation to the remote circumstance, which was extremely nice. And the UI was a pleasure. And yeah, it was just a big difference from Airflow. And now it's like a primary feature of Grail. And it's almost like a product with it, because you can just send the link for the job. And then because of how we've hooked up these links within the UI, you can actually point people to data dumps. So one of the versions that we hand over to Grail is to just say, here's your job, it's running. It'll write this CSV or object to S3, and then you can pull it in. It's a little bit different because it's an internal tool. So we have a lot of data scientists using it. So this is not like it's not like the Lyft's ETA model where the users are the people with their phones. This is more like a bunch of data scientists and software engineers. So that's not like the typical use of Flight, but it's a way that's been, a heavy way of communicating the system. So that was certainly a big one.
Interesting. And now looking at Fabio, Varsha, Brian, I mean, you coming from the engineering side, and obviously you're used to engineering principles, and you go like, well, don't give me a notebook here because I don't want to put this in production. So obviously you know that sentiment, that feeling. So for you, I mean, you didn't arrive there with a solution that's based on versioning and actually, with what you have right now. I mean, what was the pain for you to get there? And that was the first question. The second, maybe, how did you get your machine learning engineers and data scientists on board?
Maybe I can go first. So with our use cases, let's say a lot of our, and especially during COVID time, so for us, a good chunk of inputs are actually driving data. Some engineer or some vehicle specialist would go there, drive, and then get all the data that our engineers need. And around the initial periods of COVID, that was really hard for us. So we moved more to let's say a data-driven approach. And what that means is, for majority of the teams, the workflow would look something like they would want to select a scene, and that could be either an annotated data, that we would get from our vendors, or more like they would want to choose a scenario. Okay, are we going to train on a rainy day, or is it going to be on an icy road? So the first step would always be some sort of a data selection, depending on if they're from a prediction, planning, whichever team that they come from. And then the second step for them would be more like a data curation. Okay, we want to convert this data into something that our ML model can understand, either, rasters or NumPy, some sort of a curation that would happen. And then the actual model training. And once that is done, there's always obviously the validation, depending again on the team. Do they want to do it on a supervised metrics, or, an open loop, closed loop simulation, some sort of regression testing that they want. And the last step is analysis. So we figured out that these are the most commonly happening workflow. So one of the things where, to answer Ronaldo's question, Infra helped us was we abstracted a lot of these with Flight, and some more integrations that we did on top of Flight. And so that eventually the actual ML engineer would simply have to write their portion of the code, what, let's say, they want to train on, or how according to them the validation should look like, and everything else is abstracted away from them using Flight. And sorry, Martin, your question was around code versioning, right?
Yeah, and so exactly, yeah.
Okay, I think Flight provides us that feature for default. We just, depending on some internal nomenclature that we've agreed upon, every version or every change we separate into dev and prod, and use the Flight's innate versioning. And that versioning, right from the time the code is, let's say, pushed to production, that's persisted all the way until we move to the final analysis. should this model be pushed to production, yes or no? So we have that persisted all along. So it also helps us with model artifactory and to eventually trace back. I'm again on the side where, the more we invest in infrastructure, the more it's going to help our engineers, get self-driving car out on the roads pretty soon.
Yeah, I can go next. So I think it was a pretty similar experience on my end too. I think I share a lot of the pain that DJ mentioned when he was talking about going from airflow DAGs. Fortunately for us at Stripe, I think what we did was we were able to partner with a lot of our users. So my team is responsible for the infrastructure, and then obviously, the data scientists or the ML engineers are responsible for the product and generation of the models. So getting them partnered early on and understanding that they want a better way in being able to train their models and generate data was definitely the first step. And then the next one after that was which platform are we going to choose? And so from there we were able to kind of just make a short list, kind of try out POCs for each one of those. And from there it was kind of just like flight winning out in feature set and just the ability to iterate quickly. I will make a kind of, spicy take based on Ronaldo's paper, but I do think Jupyter Notebooks was kind of a pivotal piece here, because I think for us, at least, being able to speak to users kind of where they start at, which is being able to iterate on notebooks, was a starting point. And then I think because we're able to use that code base and import it into Jupyter Notebooks, and then extract that out and put it into like a flight DAG, it let them kind of interop between, production type DAGs versus like ad hoc type notebook interfaces. So that piece really worked well for us.
Very interesting. Fabio.
It's not similar, Brian, what we went through. Back in the day, before we had the first DAG to like that kind of organized pre-processing and training and evaluation and automated that, the human was the orchestrator. We used MLflow projects back then, which packages your code in a Docker image and then runs a job on Kubernetes with that image and an entry point, and then it does a training. But the problem is that once your node shuts down, the pod is gone, the job is gone. Nobody ever knew that this happened. You have a run in MLflow, but there's no, basically what you treat as the artifact is kind of the model that you train, right? And then we had, I worked in a machine learning consultancy company, and the project lasted for 1 year that we were on. And at one point we realized, okay, actually we're not able to reproduce what we ran 6 months ago, because we do have the run here. We did not log all hyperparameters. We did not log exactly how, basically we weren't able to reproduce runs. And we figured, okay, we need to do this better. First of all, we need to be able to kind of chain different tasks together, because what we were doing, and I'm a bit embarrassed to say that, but we started the training during before ending the day. Training would run for a few hours, would end in the middle of the night, but the next morning the evaluation wasn't done because somebody had to manually trigger it. So that was the first, for us that was like, okay, right now we can't continue doing it like this. We need to automate that. Then we wrote down a bunch of requirements, and an important one for us was that we need to be able to do different tasks with different resources. It's kind of a no-brainer, right? But in fact, it's pretty difficult to do that with some frameworks, or actually with the better part of the frameworks. We needed a good way to do distributed training and not have our engineers create. There was in the beginning there was a shell script that spun up compute engine instances and then just kind of set the networking so that every worker for PyTorch distributed training knew where the other workers are running. But that's not great, right? We wanted that part to integrate nicely into the DAG. And also, for example, there's Kubeflow operators, which is a great piece of software in my opinion. It doesn't really integrate well with Kubeflow pipelines. As one would expect, it really doesn't. So we had this list of requirements of what we want, which would be different tasks, different resources, different tasks, different images, be able to have distributed training with PyTorch or TensorFlow just in the middle of the DAG. We also needed Spark because we did some pre-processing with Spark. It would be great if Spark could somehow fit into the frame. And then we went to towards data science and the other blogs on Medium and looked at top 10 orchestration frameworks for MLOps. And we tried to build a prototype with the tools that we found. And we got pretty frustrated. And at one point we discovered Flight and everything was easy. And because it does exactly these things. You can specify the resources at the task level and not at the workflow level. It doesn't help you if it's at the workflow level because you don't want to reserve your GPU for pre-processing. That doesn't make any sense at all. For machine learning, you want to register to the task level. You want to have the ability to run different parts of your workflow with different images, so you don't get into situations where you have to fit all your requirements into one image because you just get to run one image. And it has boosted our productivity greatly. And also these things that we can't reproduce runs, you cannot not reproduce runs because you're forced to version, which is a great thing. And in the end, what we ended up doing is that we kind of had people who leaned more towards the engineering side configure the platform in a way that we considered as a best practice. And then we made it kind of a self-serve thing to also be able to enable ML engineers to use it themselves without putting an MLOps engineer or a software engineer on every team. So I think that sounds very similar to what you, Brian, described with creating a prototype with the different frameworks that are out there, and then just figuring out which one ticks most boxes that you have.
So I think interesting would be, so Rolando, when you contrast this, I think what we hear here is like an experience where you have a clear business problem, but you have an engineering approach going about it and bringing data scientists obviously in and giving them a system, that they can actually operate within, plus having the advantages of having connectivity to other systems and versioning and so on. Is that kind of like compared to the 18 people that you spoke, did they have severe access or good access to engineering resources to build the infrastructure? Or do you feel like they would just like put together, classical MLOps teams, use the fragmentation of tools out there, and it's a wild west and go ahead and just figure out how to sort yourself out?
So I think there were some simple solutions. I think one of the things that I learned was that folks had like a development desktop under their desk. And this is like either startups or larger companies. I think I can maybe speak of my own personal experience here rather than the transcripts. I think I noticed kind of like a movement to the cloud and then back into like a GPU development desktop. I think in 2017, we were all kind of like, oh yeah, just use AWS for GPUs. And then it became too expensive. And then we were using Slurm to schedule jobs. But then a few people dominated and they got all the GPUs, and then there was none for me. And so now I'm seeing like desktops pop up in graduate students' tables. Like everyone just kind of, it's like, screw it. I'm getting my own GPU and I'm controlling this GPU. But again, it's like, yeah, okay, now you have velocity, but then maybe your GPU, maybe your development desktop has a different operating system or a different version of TensorFlow and CUDA than does the distributed training environment in the cloud, So then you have to manage that like version drift in operating systems and stuff. So, it sounds like it's being actively negotiated what the right balance is.
Yeah, I remember when I went to the cloud and then I decided to buy a DGX because it's so much better to have this in the office. So I understand that feeling. I think, Fabio, what you said earlier just was a really interesting point. You said the separation between workflows and tasks is really kind of like where you get actually the benefit when you focus on tasks and you have granularity and you can actually leverage your resources. But we also know that notebooks are really, not just like a task, they're potentially a lot more. So how do you get data scientists or machine learning engineers that are completely notebook driven to a task mentality? What is kind of like the impetus to help them to understand that, or not to understand? I would be wondering about, Michael, DJ, what your thoughts about notebooks versus really functional task-driven approach to machine learning.
I mean, I personally think that they're a necessary evil. I don't think that they're good to rely on in general, and no final version of code exists in notebooks, but just that human interaction. And so many people are just accustomed to it. So, but it seems like other people's workflow involves, migrating that out as well. But in terms of, I think it works against you in terms of versioning because notebooks change constantly. For a while, they weren't. I mean, GitHub only recently added that integration that allows you to um, inspect them well. They also are just like not. They're it's not very opinionated with respect to state, and debugging things and keeping track of errors requires that state is almost like a fixed feature to keep track of. So we've just found that, like for example, someone will take a notebook, they'll have some results in the notebook, they'll then export a chunk of code out into a PR. Then they'll reference the notebook for why that piece of code should work. Someone believes it in the PR, it gets merged in. Later, you find out that that piece of code was not what you thought it was. And then like, oh, actually, it was because, I ran the cells in a different order. I mean, that is kind of a sort of a contrived examples, but things like that happen a lot. Pulling stale data is one that we've seen. So in general, I think that they are a source of errors, but if you want to get that model developer friendly environment, you sort of have to use notebooks.
Yeah, yeah. And we have about 6 minutes left. I would love to bring this together and make it useful for people who are not quite there, maybe where you are, or still fighting with the elements, so to say. So if each of you would give one piece of advice, right, about looking back and in hindsight, everything is 2020. What would you want to tell somebody who's in a similar situation as you were maybe 2 years ago or a year ago, in order to do differently or then better, so they get to the point of maximizing what Rolando says, the velocity, do validation earlier, and have versioning. So what's the secret formula? Do you need to find people? Do you need to collaborate more? Do you need to look just at systems? Is a combination of all of that? So if you want to go through it, would love maybe Brian, top right. If you go give Brian from 2 years ago some advice, what would that be?
Yeah, I think for us, the thing that I don't think we looked closely enough was definitely that first V, which is velocity. I'm also like, I can throw another question out to the panel because I am also curious, but like, how do most other people measure velocity? So we take a very naive way right now, which is looking at number of experiments run. And so like looking at that, we can tell like having infrastructure that allows you to iterate faster, allows you to add more experiments. One of the things that allowed us to do that was moving over to Flight, having the versioning, having the ability to iterate quickly. And so, yeah, I think just that first V, I think, is what speaks loudest to me, and to always be monitoring that in your system.
Fantastic. Varsha? If you would give Varsha, if you would give yourself some advice from a year ago, what would be the number one most important piece of advice?
Version everything and make sure the version is persisted all the way through. Yeah, and I think to add about the previous discussions you were talking about, right? Having your own GPU and having your own workstation versus, when you move to production, things are very different. Flight has enabled us to, write in such a way that we could test them locally. So all of us have a cloud workstation with GPU enabled. So we could do that locally, and it's the exact same environment we get on, production. So versioning and that would be one thing that I would tell myself from 2 years back. Yeah.
Okay, good. We're going to take some notes. And Michael, how about yourself?
We actually started 2 years ago, basically. So that's like starting from the very beginning on the MLOps platform bit. I would say for us, it would be really coming up with a strong test case on being able to say this is like the golden standard for the models that we're trying to train, and then making sure that we're able to maintain like what is the fastest time we can get to creating that model with the least amount of pain for a user. And so we didn't really keep that in the beginning, and so we focused a lot on creating all these different components, but we didn't focus on like the quality of the model itself as much at the time. And I think that could have helped us. As I had said before, we have like really strong data scientists that can create their own models, and we can serve them, and they understand like our platform. But we're also working on the other part where like you're not a data scientist, but you kind of know how models work, and you know you need to add permutations, and you know your data set, and you know like this model architecture should work, and then you can test your model once it's done and see that it works. We didn't focus on that strongly enough from the beginning, I think. And maybe that's just a use case that we have. I know that at other companies, like you have strong data scientists that, like that's where you're building the MLOps platform for. But for us, we have also different use cases.
Yeah, I don't think you're alone. I think there are a lot of companies actually even outsourcing the data science part and don't have any of that.
Yeah.
So I think that's quite common. Okay, very good. DJ.
So when we were first developing the system, we were operating on, everyone at that point was bringing their own pieces of advice. And one was, build the simplest pipeline that does the thing that you're trying to do, and then start with the metrics and then start optimizing those metrics. In doing that, I think we made a mistake, which is you have to build, it's easy to create a pipeline that actually isn't on the path to building the final pipeline, where that first pipeline you should actually just eliminate almost entirely. So I think thinking about the full pipeline with all the components, the remote compute, the fact that you're using data across a lot of different developers, like the full infrastructure, needs to be represented in that first version of the pipeline, which does slow it down. And then things like model iterations and caring about predictive act, like all those things, those come later. But what this ultimately means is sort of a refinement on that piece of advice for that first iteration is to really schematic the whole thing. Just that design period is incredibly important because we actually had to just like rewind after a year into the whole thing and redo a big portion of it. So that would have been quite helpful to know earlier.
Fantastic. And Fabio, I assume you agree with the architectural approach.
Yeah, when you asked the question, I was thinking what I was going to say. I'm going to say, tip to myself maybe 3 years ago when I was in a team of 5 machine learning engineers, kind of in an incubator trying to build a company around machine learning services. My tip would be overcome not invented here syndrome, because back then we were kind of considering, okay, we're not Docker, we're not Compute Engine or EC2, let's just kind of make that work together with Python and build our own container orchestrator. My hint would be don't do that. There is an industry standard. Learn Kubernetes. There's a great variety and set of awesome MLOps tools for this platform. Learn that platform, and a lot of sorrow will go away. So overcome not invented here syndrome, I would say, and just use great tools that have developed over the last years.
Fantastic. Rolando, I want to give you a last chance to engage with the panel as well. Is there anything you wanted to ask them before we close out the session today?
Yeah, thank you, Martin. So I was thinking about, like, what's something that I learned from the interview that I wish I could take back in time. Maybe from an academic setting is we have this habit of evaluating things in a vacuum. It's kind of like what DJ said of like, we have a model training pipeline and then we build this model training pipeline and then we try to find an application that wraps it. And that's a mistake, right? I think product validation is what matters. If you start thinking about product metrics like revenue, key performance indicators, then that's going to kind of drive you naturally towards collaboration with other stakeholders. I also think that in machine learning, once you reach a certain threshold of performance, then if you're going to iterate, it makes more sense to iterate on the application or the software, maybe a heuristic or a filter rather than the machine learning thing per se. So that's just kind of like, before you start with machine learning, build out the application infrastructure and then, see where it belongs in the global scheme of things and then iterate on the model then. So I would say like validation was my takeaway.
Fantastic. No, I feel like this is, there's so many other topics here today. The product component, I completely love that topic about metrics that are other than an F1 score, right? Or whatever we do, the imbalance and so on. We also want to look at, is what we build really valuable or not? That's a component. Are we actually discriminating with our models against people? It's another dimension that is really huge. Think about models and the Fair Housing, Fair Credit Act and so on, that use data sets that are potentially locally drawn from an area where the demographics is all the same, right? And so you have to think about what you're doing there. So at the essence, what we do is really kind of a mixed field of where you have to have range. I think to me, what you're describing with your 3 V's is range, and that range is entropy, and that entropy over time will go in different ways. And what you have to have is a really solid and robust system to bring it together and give people a chance to communicate and collaborate. And I feel like this allows us to learn and get better. And I feel like very often people don't start at that level, they just get themselves to that level. And so I just want to say thanks to each and every one of you. This was really, really interesting. I would love to do a second part about business metrics in other areas and bias in models and so on. And how when you have like F1 score, specifically F2, which is my favorite topic for credit fraud and so on. But I just want to say thanks. If there's anything else anybody wants to say right now, is your last chance. If not, looks good. Right, everybody's good. Then we're going to close this out. We're going to have more information on the website, and I look forward to seeing the panel again. I just want to say thank you very much, each and every one. This was a real pleasure. Thank you. Goodbye.